In this lesson, we're going to be talking about model diagnostics. Specifically, we're going to be talking about checking the assumptions of our model. So hopefully you guys can recall that in multiple linear regression, our statistical model looked like this, where we made the assumption about this error term right here. We said that this error term was normally distributed, centered around zero, with some variance, and that they were independent and identically distributed. What this assumption really comes down to is we're saying that our residuals are normally distributed. Our residuals have constant variance. So this constant variance comes from the fact that this sigma squared is for all of our epsilon and there isn't an I. There are cases in models where this sigma squared does have an I and it can vary for different observations. We're not covering that case. We're also saying that our residuals are independent. So one observation doesn't impact the next observation. If you do have that type of scenario, you probably want to look into time series analysis or analysis that can incorporate that type of covariant structure within your model. We're also saying that our residuals have a mean of 0, and that's where this 0 is coming from. So to check these assumptions, we need to investigate and look at our residual values. Recall that our residual values can be thought of as what's missing. And what's missing in our data is between what is observed and then what is predicted or what we expect. So our predicted values are what we expect. That's coming from our y hats. So our residuals are the difference between what we observe minus what we're going to expect the data to give us. Now, we want to check, we need, not that we want to, we need to check our assumptions because we could have a model that has great statistics like we were talking about in lesson 14, but that model becomes invalid if our assumptions aren't met. Typically, if your assumptions aren't met, you can do some type of various things that we'll talk about, or maybe multiple linear regression isn't the method for your analysis. So it's always good to check these assumptions. Before moving on and briefly talking about where this lesson's headed, let's just visually look at what we mean by our assumptions using a picture. So hopefully this picture looks familiar from our last couple of notes in lesson 13, I believe. And the whole idea is our residual here. This blue observation is our y, I. This point right here is our y hat, I. And the residual is the distance between these 2 points. So the residual is this green line, EI. And what we say, or what we're saying by making this assumption up here, is that our residuals are going to be centered around where we're predicted, and it's going to have a normal distribution around it. So it's going to lie somewhere in here where we'd expect most of the residuals to be near the middle of the data, near the middle or closer to the predicted line, okay, and vary with some sigma squared. Okay, we can also draw it here. So here we would expect the data to be mostly around our predicted value. The reason it's going to be around our predicted value is because of, if we look up at this model, we take the expectation across, we would expect this, which would be our predicted, and then the expectation of our residual is 0. So again, we're expecting our residuals to be centered around what we're predicting at and vary with some normal distribution with the variance. Okay, now we're going to be using a lot of different plots and to help us understand if we're breaking our assumptions of our data is not normal through using transformations, if our data is nonlinear. If your data is nonlinear, I would suggest playing with your predictors. Maybe one of your predictors needs to be squared because it's showing a quadratic relationship rather than a linear. And then if we don't have if we have non-constant variance, we also have to adjust. Some of the tools we'll be talking about are scatter plots of the response against the predicted, normal quantile plots. This is also known as QQ plots. We're going to be looking at residuals, where this one, the residuals against the predicted, is a big plot that we use. And then we'll also be talking about partial regression plots, or this is also known as added variables. So in our next lesson, we're going to start talking about the assumptions and how we check those using our residuals.